Hi everyone, today we're doing exercise 7C using the rule to model linear growth and decay. So today we're learning about writing rules that define linear growth and decay. So pretty much what we learnt about last lesson, except last lesson we learnt it as a recursive rule, whereas today we're just going to learn the nth term rule, which is actually a lot easier to use. What you need to be able to do is to convert a recursive rule to the nth term rule, to create an nth term rule using a financial scenario, and then complete various financial problems related to linear growth and decay, all about using that nth term rule. So what is the nth term rule? What's the point of it? Basically, well, you would have noticed with recursion that you needed one term in order to find the next. So if I wanted to find V2, for example, I first had to find V1. And that would be really annoying if I need to find V10 or V100. Like it just won't work. It's not reasonable to do that. So what we're going to do is we're going to do something called the nth term rule. So essentially this rule allows me to substitute whatever number I need to. So for example, if I need to find V20, I can just sub in n is equal to 20 straight into the rule and that'll spit out the answer for me. So the first part of the lesson, I'm just going to quickly talk about how we create this nth term rule and the specifics of the rule. And then from there, we're going to go ahead and apply the formula. So let's first talk about creating this rule. How does this rule even work? Now, here are different n values. So, you'd usually have V0, V1, V2, blah, blah, blah. And here is your rule. So I know that says P and I'm talking about it in terms of V, but you can imagine that it's the same idea. So for example, when n is equal to 0, what would V0 be? And I mean, that's given to us straight away. That's just 20. Sorry, not sure why I'm writing in red. Let's try that again. That'll be 20. Now, this is the key to it. D added since V0. Now, D, remember, is how much I'm adding on to each step, I suppose. So usually it's the interest if we're talking about it in financial scenarios. If it was just a random rule, we're just talking about it in terms of how much is being added on. So at this moment, nothing has been added. Now, after one iteration, so we're at V1, you would have noticed all I'm doing is I'm adding 2. So Vn or V1 would be 22. And in total, I've added 2. Now, if I go to V2, again, all I'm doing is adding 2, so it'll become 4. So even though I've just added 2 in that scenario, so I added 2 before, I'm going to now add another 2 overall, so that in total, I've added 4. So I started off at 20, now I've gotten to 24. Then I'm going to do V3. Again, I've gone up by 6. So now I've added 2 the first time, 2 the second time, and now 2 the third time. So overall, I've added 6. Now, you might already start to see a pattern emerging. So we've got 3 times that I've added 2, and n happens to be 3. 2 times that I've added 2, n happens to be 2, and so on. So it's not just a coincidence. That's actually going to help me figure out how much I need to add initially. So for example, if I started at 20, and I know that after 3 times, I'm going to add 6 because that's 3 lots of 2, and where 2 is D, then I can just add the 6 directly onto the start, the 20, so I end up with 26. So hopefully you can see where we're going with this. Here's a table that kind of explains a little bit further, so you can see that whatever my n value is how many lots of D that I'm going to add. So D every time here is 2, but if I want V4, for example, I'm going to do 4 lots of 2. So overall, I'm adding 8. You can see that then I can figure out how much am I going to add in total, and then I can just add that directly to V0. I don't have to worry about 1, 2, 3, and so on. I can just add that directly onto V0, and that gets me straight to my answer. So that's basically how this rule has come about, and this is what the rule looks like. So Vn, which is going to be my final value, or well, actually we always usually we call it current. So our current term is equal to our initial term, plus, and then we have ND. So N is just the term number, I suppose, term number, and then D is the amounts of interest or whatever else that D might be representing in that situation. It's how much I add on. So this gives me a rule, and basically it means that I can substitute any value for N, and I'll get straight to my answer. I don't have to figure out V1, V2, V3, and so on. Depending on the situation, if it's going to be a simple interest loan or investment, you add, as we learned last lesson. However, if it's flat rate depreciation or unit cost depreciation, we subtract. So it's just whatever the scenario happens to be. So let's go ahead and apply it. So we've got in example 12, the following recurrence relation can be used to model a simple interest investment. V0 is 3000, Vn plus 1 equals Vn plus 260, where Vn is the value of the investment after n years. So part A says, what is the principal of the investment? So this is the first thing, principal. What do we start with? So we can just write the principal is equal to 3000. So that part of the question is done. And then how much interest is added to the investment each year? So how much interest is added? That's talking about our D value. And we can read from the question that D is equal to 260. Now these are the two key things, because for part B, it's asking us to write the rule. So a general rule looks like this. So our current term will be equal to the initial term plus n times D. So Vn is going to equal to 3000 plus 260n. And so now I can just sub in whatever value of n and it'll multiply by 260 to give me that many lots, and then I'd add it to the initial value. So then part C says use a rule to find the value of the investment after 15 years. So V15 will be equal to 3000 plus 260 times 15. We'll have to do that on the calculator. So that will be 6,900. And for the last one, use a rule to find when the value of the investment first exceeds 10,000. Now this is the really cool thing about the rule. With our recurrence relation, there we go, we had to keep pressing enter until we got to over 10,000. But now, because I can write a rule, I can actually use a function on the calculator called solve. So 10,000 is what our Vn is. So I would highlight 10,000, and that's what I want it to be. That's it, that's the Vn. That'll equal to 3000 plus 260n. So if you forgot where I got that, that is our rule. Vn is 10,000, and then that is our rule there. And I want to figure out for what value of n is it going to equal to 10,000. Now on your calculator, you can go to menu 3.1, which is menu, solve, menu, algebra, and then solve. So I'm just going to write in your calculator instructions. You wouldn't write this in a test, but I'm just showing you how you would do this. So menu 3.1. It's a really important thing for you to know. So we'll go to menu, algebra, solve. I hope you're doing this on your end while I'm doing it. I'm just speaking it out. And we're going to type it in. So 10,000 equals 3,000 plus 260 times n. And then we write comma n to tell the calculator what it is that what we want it to find. So we get n is equal to, actually we would write this part, n is equal to 26.9. So what's happened here is that at 26.9, so it's within the 26th year, we haven't, that's the point at which we exceed 10,000, but we want to find it at the end of the year. So after how many years is that going to happen? So in this case, what we're going to do is we're going to round up. In fact, we're always going to round up, because even if I got 26.1, it hasn't happened yet by 26. So we have to always go until the next year. So this will be 27 years. So always round up. All right, next example. So Amy invests 4,000 in a simple interest investment of paying interest at the rate of 6.5% per year. Use a rule to find the value of the investment after 10 years. So first thing, as always, we like to do is to highlight. So she invests. Invest is an important word because we know it's going to be a plus. 4,000, we've got a simple interest investment of paying interest at the rate of 6.5% per year. And then the instructions are to use a rule to find the value of the investment after 10 years. So I've gone ahead and done my highlighting. Now I'm going to annotate. So investing, as I mentioned, is a plus. 4,000 is my V0. Simple interest investment. So I'll just quickly write the rule so I know what I'm doing. So I'll remember that. The rate is 6.5%, and then it says use a rule, which is quite convenient because I've already written that out. And we want it after 10 years, so we're looking for V10. All right, so I'm just going to write down some key information. First thing is the rule that I have, and I need to find V10. Now, in order for me to find V10, I need to fill in V0 and D. So that's what I'm going to be looking for, V0, D. Now, V0 is very easy. They tell me exactly what it is, but D, I need to do a little bit more digging for it. So what we're going to do is write out our formula. If you remember, D is equal to R over 100 times V0. So in this case, it's 6.5 over 100 times 4,000, and that's how much interest I'm going to be charged per year. Onto our calculator. And I get $260. Okay, so that means my final rule is 4,000 plus 260N. And then now if I want to solve for V10, so what's happened after 10 years, I can go ahead and substitute 10 into there. So we can put that straight into our calculator, and I get 6,600. Example 14. The following recurrence relation can be used to model the flat rate depreciation of a set of office furniture. So we've got a rule there. We're noting the fact that it's a flat rate depreciation, so it's going down over time, and where Vn is the value of the furniture after n years. What's the initial value of the furniture? By how much does the furniture decrease each year? So initial value is V0, and then how much it goes down by is D. So we kind of just need to read this off of the rule. So we can see we've got V0 here is 12,000, and then D is over here, which is 1,200. And now we need to convert the rule. So the rule, as we know, is Vn is equal to V0 minus Nd, because it's flat rate depreciation. So in this case, V0 is 12,000 and D is 1,200 N. Then part C says use it to find the value of the furniture after 6 years. So we are looking for V6. So V6 will be equal to, we just need the rule, so 12,000 minus 1,200 times 6. Straight on the calculator. We get 4,800. Final part, how long does it take for the furniture's value to decrease to 0? So now we're looking for when Vn is 0. So very similar to what we did before. We're just going to make 0 equal to the rule, and then we're going to solve on our CAS. So again, I'm just writing this in here. You wouldn't usually write this on a SAC, but I'm just giving you the instruction. So we're going to go ahead and solve that straight on our CAS. And I get n is equal to 10. So it will take 10 years to decrease to 0. All right, next one. We've got a photocopier in the office. It costs $6,000 when it's new. The value depreciates at a flat rate of 17.5% of its new value each year. What is the value of the photocopier after 4 years? So by this stage, hopefully you've gotten used to these questions. I would suggest that you pause the video and give it a go yourself, and then check in to see whether it's correct or not. So first thing I would like to do is to highlight. So we've got a photocopier at $6,000 when new. You can annotate as you go along, or you can annotate afterwards. Its value depreciates. So this is a really important word because we know it's going to be minus, and flat rate tells me what rule that's going to be. So I'm going to quickly write that rule out. That'll be V0 minus ND. At 17.5%, so that's R is 17.5 of its new value. What's the value after 4 years? So this is what I'm looking for here. I'm looking for V4. Okay, so in order to be able to figure this question out, we first need to write out the rule. So I know that V0 is 6,000 and I need D. So we can just write ND and then kind of do something on the side to be able to find it. So D is equal to, remember, R over 100 times V0. That'll be 17.5 on 100 times 6,000. That's 1,050. Okay, so my final rule is going to be 6,000 minus 1,050 N. So this is the rule that I'm going to use. Okay, so the question is asking me for V4. I'm going to substitute 4 into the equation to be able to find out what that value will be. That's going to be 1,800. All right, final example. We've got a hairdryer and a salon. It's purchased for $850. The value of the hairdryer depreciates by 25 cents for every hour it's in use. So again, key information. Purchased for $850, that's going to be V0. And it depreciates, so it's going to be subtracting by 25 cents for every hour it's in use. Now remember, when it's about usage, what we're looking at is unit cost. So it's not like D equals R on 100 times V0 does not apply here because it's not about a percentage, it's about how much it is used. So in these questions, it's actually quite convenient because they give us D as it is. Now just note that because V0 is in dollars, we need to also write D in terms of dollars. So that would be 0.25. Depreciates means that it's minus, and again, because it's unit cost, we can just write out the rule. Oops, sorry, my pen's gone crazy. Bn is equal to V0 minus ND. All right, so that's the key information highlighted and annotated. Let's go ahead and answer the question. So it says, write down a rule to find the value after n hours of use. So n represents the how much it's being used. So Vn is equal to V0 minus ND. Vn is equal to V0 is 850 and D is 0.25 n. Part B then says, what is the value of the hairdryer after 50 hours of use? So in this case, n is equal to 50. So we want to find out what V50 is. 850 minus 0.25 times 50. That's $837.50. Lastly, on average, the salon will use the hairdryer for 17 hours each week. How many weeks will it take for the value of the hairdryer to halve? So how many values will it take for the hairdryer to halve? That's what I wanted to highlight. Okay, there's a couple of parts to this question. The first one is we know how much, or they've told us how much they use it a week, because they're wanting their answer in terms of weeks, not in terms of hours. So we're going to come back to that in a moment. The key part to this question is it's asking us how long will it take for the value to halve. So that means we want 1/2 of V0. That's what we want Vn to equal to, half of what it started off with. So what term I'm looking for is V0, 850, and we want 1/2 of that. So you can put that in your calculator, or you can just half it if you know in your head. So that's $425. So we're trying to figure out how many hours does it take for it to hit 425. And then I just want you to remember, we're not looking at hours. It doesn't ask us for hours, it asks us for weeks. So we're going to come back to that, but n is in hours, so there's nothing I can do about that. Let's figure out how many hours it takes. So Vn we know is 425 is equal to V0 minus n, sorry, not n, in this case it's just D, times n. And we're going to be looking for n, which again, remember, is the number of hours, not the number of weeks. So that's straight on your calculator. I get n is equal to 1,700 hours. Now this is not my final answer because, again, I'm making a big deal of it because it's about reading the question. They haven't asked me how many hours it takes. They've said how many weeks does it take. So if every week I use it for 17 hours, and this is going to happen after 1,700 hours, all I have to do is divide it by the number of hours I use it per week to convert it to weeks. So this is hours, this is hours per week. So to get that weekly rate, so how many weeks it's going to take, I'm going to see how many times does 17 go into the total number of hours. If you put that on your calculator, or of course, again, if you know, you can just write that will take 100 weeks. All right, that's the end of 17C. I hope you found that pretty straightforward. Feel free to watch the video again, copy down the notes, and if you have any questions, you are always welcome to ask me next class or over email at any point. Take care.